Tonight I'm going to talk about building an AI image editor. And there's only a certain amount of building to be done. I'm just going to put my phone into Do Not Disturb. There's lots of we've done talks before about AI, and I did one a little while back about writing a book using a tool which allowed you to connect lots of different blocks together, and we're going to do a similar thing tonight, but this time we're talking about making pictures or modifying pictures, editing pictures. And it stems from a challenge that I took on. So Ariel's a model that I've photographed for about 12 or 13 years now, and this was a picture on the left that I took of her last year, and then there's some pictures on the right which I took of her 2012. And so I've been trying to take pictures of her in order to write a book, because I find it easier if I've got a photo, I can describe it in the book more accurately. But then it occurred to me that I've got all these pictures of the different scenes in the book now, and I could actually not only make a book, I could make a comic book. But she pointed out to me that her pictures probably don't look quite right, because some of them were taken in 2012 and some of them were taken in 2025 and so they're not all they won't look exactly right. So I thought, I wonder if an AI can actually do it, and in fact I rashly assumed it could, and rapidly found out it was slightly more difficult than I thought it would be. But I thought you might like to see the challenge. So I'm using some tools, a thing called ComfyUI, another thing called Quen Image Edit, or I think that's how you pronounce it, a thing that I call Z Image Turbo, but all the Americans called Z Image Turbo, and another thing called AI Toolkit. And by using these various AI tools, I've been able to make Ariel look like a cartoon. So let me take you through a little bit about how these things work, and then we'll do a demo, and hopefully we'll be able to take a picture of her that I haven't yet converted into a cartoon and make into a cartoon. We'll see. So what are these things? So the first thing, ComfyUI, it's a bit like that other tool that I showed when we were doing the AI that helped to write a book, or tried to write a book, I should say. It's a drag and drop way to link software modules together. The main difference is it runs on Windows, or it will run on Linux or a Mac. So it's quite a flexible bit of software, but basically you can have all these various modules and link them together, and so build a system to do a particular job. So and then the next tool I'm going to use is actually what's known as a image model, and it's called Quen Image Edit, and it's an AI model that's been trained to edit images. So it's been given millions of images, two versions of each image, one before and one after, and then it's been given a bit of text that describes the change between the two images, so that the image you can basically use that text, because it's learnt what the text means. It allows you to edit an image. And then I'm going to use another bit of software called Z Image Turbo, or Z Image Turbo. In fact, this has been around for a little while. I think in terms of time scales, ComfyUI's been around for a couple of years, but it's been improving and improving over the time. In fact, the one problem with ComfyUI is it seems to be it seems to be improved on a daily basis. So almost every day when you log into it, it's slightly different from the day before. Qwen Image Edit, there was a version first brought out in September last year, and the version I'm using now is one from November, which is a better version. Z-Image Turbo is interesting because it's been trained to generate images from text. So you give it a piece of text, a description of an image, and it will generate an image for you. But it's a fast model. And there are two versions of Z-Image or Z-Image. This Turbo version, which has been designed to run really quickly, and one without the word turbo. People are tending to call it Z-Image Base, which is much slower, but it's much better at or it generates better images, apparently. But it takes a lot longer, so you get bored watching it. And then there's a thing called AI Toolkit, and AI Toolkit can be used to train models. So you can give it images, and it can be used to train either Qwen or Z-Image or several other models. And you can give it images that and a piece of text that describes the image, and so it will learn how to generate an image using that piece of text. So what I've done is I've used a combination of these things to create slightly modified versions of photographs I've taken recently, so that Ariel looks as she did when I first started photographing her. So let's go into the details. So what is an image generation model? So basically it's something where you can give it a piece of text. So for example, I can say I want a photo of a ginger cat sitting on a mat. I'm going right back to school, aren't I, with a cat on the mat. And then we use this thing called the diffusion model. And the reason it's called a diffusion model is because the process is known as diffusion. The first diffusion model that came out was called stable diffusion, but there are lots of different models now. Stable diffusion is still quite popular, but it will generate a cat on a mat. And this is one I generated yesterday using. For some reason, I decided I'd see if it was better with Z-Image Base, so I generated this one with Z-Image Base. And as you can see, it took me literally, there's the mat and the cat, and it's a ginger cat sitting on a mat. So it worked pretty well first time. But how did we go about doing it? Well, you need, in order to make all that work, you need a ComfyUI workflow. And this is a simple workflow which does something along those lines. So you can see on the left hand side, can I point at this thing? Maybe not. Hang on. Yeah. So on the left hand side, we load what's called, it's got this module called load a checkpoint, and what we're talking about in terms of a checkpoint is it's actually the model that was created. It's one of these big models. It's been trained with billions of pictures with billions of descriptions. So it's a huge model. It basically consists of some huge multi-dimensional matrices, which it's learnt what the description, it's been trained to learn what is interesting in a picture. And in this example, this is the example that comes with ComfyUI when you first turn it on. beautiful scenery, nature, glass bottle, landscape, purple galaxy bottle. And it draws a picture of a bottle with a purple galaxy in there. I haven't done that, but we could do it later if you like. Oh, I can do the mouse over. It's working now. You see it's got two text prompts here. It's got what's called a positive prompt and a negative prompt. And so this is the positive prompt, the things we want, and you can tell it a bunch of things you don't want to see.
I can't read that.
Yeah, sorry,
Too small for me to see.
Unfortunately, it is that. This just says text and watermark. So because it's been trained with lots of images from the internet, a lot of them had watermarks on. So it's a good idea to tell it you don't want a picture with a watermark. Then it basically takes these things, the bits of text you've wrote, and encodes them, and it then feeds them into this thing called a K sampler, and then the K sampler does the first part of the process. It sets up the number of steps we're going to go through. Here it's saying we're going to go 20 steps. It sets up a thing called CFG, which is how much diversity it can add itself at random. It sets a seed. I'll tell you a bit more about it later, and it sets the sampler name and the scheduler and how much denoising. I'll go into that a bit more, and then it takes you into this thing called a VAE decode, and then eventually you get an image out at the end and you can save it. So I'll come into a bit more detail about that in a little while. So you can make a much more detailed prompt. The more detail you put into it usually means the better the thing's got. So here we've got a description, and I'll read it to you in case you can't see it. It says, a detailed photograph of the exterior of a vintage cozy bookstore cafe at twilight. Warm light glows from the inside. Above the main entrance, a large hand-painted wooden sign reads Basingstoke Makerspace. On the pavement in front, there's an A-frame chalkboard sign with handwritten chalk art that reads, Today's special, build an AI photo editor with ComfyUI and Quen. Now serving Quen Edit 2511. In the main display window, a poster on an easel has a printed text that says, upcoming event, open evening, Tuesday at 7 p.m. So, again, I ran this through Z-Image, and I got this out, which I think is pretty good, except it didn't put the upcoming event. It's not in the window, it's in the doorway, but it was pretty accurate. I thought that was quite good. I tried generating a few more. It never actually put the thing in the window, unfortunately, but I gave up in the end because as I mentioned, it takes a little while to do the generating, but it does generate quite interesting pictures. So what about image editing? So we've got this picture that I generated earlier with the cat, but I want to use an image editing model. So the main difference between an image editing model is that the text you give it is just the text you want to change, and you give it the picture you want to change. And it can change it quite a lot, as you will see. So I fed this into Quen, which is the image editing model. And the difference there is, of course, Quen can take the text as well as a picture, and then it generates a picture of the cat. Now, I don't know whether this is exactly the same cat. It looks like it's got slightly different number of stripes on it. So I think it's done a sort of job, but it's not perfect. So, you know, it's a similar cat, not the same cat, I would say. But somehow it's worked out. It's still ginger. It's still. I had changed this. The text said, change this photo so the cat is sitting on a wall on a sunny day, and that's what it generated. So here's an example of the workflow. You can see it's getting more and more complicated, and you might think, well, how could I make such a thing? Well, the truth is I didn't make this thing. I downloaded it off the internet. The workflow was designed by somebody else, but basically it will, this particular model will take up to 3 photographs and it will merge them together. So I've actually only taken one in at the moment, but I have tried taking multiple pictures in. And you basically upload a picture, you can then give it some text. So it just, this one says make this photo into a drawing in the style of John Willie. So basically I'm hoping that the model knows what that means, and we'll see a bit later on whether it works. So how does it work? How does all this stuff work? Well, we've got these various bits. There's the thing that's called the variational autoencoder, and what it's doing is it's taking a picture when you're training a model and converting it into a big array description of the picture. It's then identifying from multiple pictures and multiple pieces of text what the common things are about the pictures. So it basically converts all the information into what's called a latent image. So it's not actually storing pictures or pixels, it's storing like its internal multi-dimensional version of the picture in as a big multi-dimensional array, or and it's what's called latent space, and it's called latent space because the idea is it can be used to create another picture. So in order to do that, what they do is they compress the picture and add noise. So you end up with something. This is an example of something. It was part way through being compressed and made into an added noise. If I waited until the end, you wouldn't see anything sensible at all. It would just look like a blur. But this was part way through, and I stopped it part way through to see the example from that picture. And then it goes, it learns how to remove the noise and make the picture again based on the text that you've given it. So it goes round and round this loop multiple times, thousands of times, and it goes round and round the loop for every one of the billion pictures that it's doing, and it learns each time it goes round the process. So in order to use a trained model, we enter the text prompt, we tokenize the text so it gets converted into an array, we generate the noisy latent image, and then we load the model into GPU memory, extract a latent image that matches the prompt by going around this loop, the K sampler and the VAE decode. And if you remember, in the parameters at the beginning, it was, you could say the number of times round the loop, and we were choosing 30. The nice thing about the Z image turbo version is you can actually do it with only going around the loop 4 times. It will generate a reasonable picture. Okay, so we're part way there. We can generate images, but how can I generate images that look like Ariel did in 2012? I need to train the model a bit to know what Ariel looks like or looked like in 2012. So in order to do that, I'm going to use this thing called low rank adaption. And what low rank adaption does is it makes a small array which just represents the bits of the thing I want to generate that the model doesn't know about so far. So I freeze the original model, and then I add some small trainable matrices which inject into the model later, these adapter layers, and this then allows me to tell the model I want it to look like Ariel, and it will learn what she looks like, and then it will then be able to train, it will be able to make changes like that. So in order to do that, we first of all have to create a training data set. To do that, we can use Photoshop, or in fact, we can use ComfyUI. And then we use this tool called AI Toolkit, and that can be used to do all this stuff, initialize the LoRA adapters, go round this training loop, and for each training image, encode the image into latent space using the VAE encoder. Then we can add noise. It will predict what the denoise version should look like using the model, calculate the loss, and back propagate, and it goes around this loop. And it has this process. I won't be able to run it tonight because it generally takes 4 or 5 hours. It can take even longer. It depends how many times round the loop you go. I've found that for most of what they recommend going around 3,000 times around this loop, and I've found that's actually generally not enough. It needs to be around about 5,000 times, so it does take quite a long time. But the first step is creating a picture or set of pictures that look like Ariel did in 2012. So what I've done here is I've actually used a ComfyUI workflow to help me do it. I found one where I can take one of my existing pictures. So this picture on the end is the one I photographed, and then I can give it a bunch of prompts so that I can make it look like a zoomed in version, a zoomed out version. It's even invented the fact that she's wearing a black dress. I'm happy with that. And then it will show different views. It's worked out what she would look like if you turn the picture 45 degrees, 90 degrees. If you looked down on the top of her head, if you looked up from below, if you looked the other 90 degrees, or the other 45 degrees and the other 90 degrees. So by doing that, I've saved myself a lot of effort, because I was trying to find pictures, first of all, but I never take a picture of the side of her face, it just didn't happen. So I didn't have the right pictures. But this workflow was able to generate pictures. It's guessing a little bit, it's guessing a lot about what she looked like from the side, but it's not that far out actually. And it's used, just trying to remember which model it used. I think it was Quen. Yeah, it was one of the Quen models to do that. It's actually Quen Image Edit it's used, yeah. So this workflow, again, I found it on the internet, downloaded it, and it's done the job. It's saved all these extra pictures, so I can feed it into the training. So in the training, I need to describe each picture, and that can be a bit tedious, but luckily I found another model that will do that for me, a model called Florence. And basically you can feed Florence a picture and it will just turn it into a description. So most of these descriptions have been generated that way. And when I'm generating the descriptions though, I have to name them in a way that I can then use to drag out that picture that I want. So Ariel's real name is Jocelyn, and I've just changed, I've said in each case a photo of Jocelyn, but I've changed the O in her name to a 0. So it's not something that's going to get typed into the model or into a description normally. It's going to generate it's going to learn how to generate these pictures by using the model, by using that name as a keyword. So then, in order to run AI Toolkit, you basically have to fill out all this stuff. So you choose the name of the data set you want to create, or the LoRA you want to create. You put your trigger word in. You say where you're going to run it. I've only got one GPU on my computer, so it's always GPU 0. You choose the model that you're going to create it for, and then is to say where to find it, and you set up various parameters. These were all the recommendations I got for this particular model, for the Z image model, and so it's all fairly straightforward. And then during the process, you can choose how many steps you're going to go through and what size of images you're feeding in. I've made all my images 1024 square, so they're all 1024. And then during the process, every 500 steps, I generate a bunch of images to test how it's going. So here you can see, there's various different prompts, and it's going to generate an image for each prompt. And again, I've used the special keyword I've put in to describe her. So I've said a woman with blonde hair playing chess in the park. I've said a woman with blonde hair holding a coffee cup in a beanie, sitting in a cafe, and a woman with blonde hair is a DJ at a nightclub, fisheye lens, smoke machine, laser lights, holding a martini. And there was a couple more prompts as well. And then it's gone through and generated all these example images. This is towards the end of the process, so this is the last lot of images it's created. And you can see it's done a pretty good job. It does look exactly like her, which is, I think actually in my original thing, when I was generating the picture of her playing chess in the park, I had a bomb going off in the background. So there was a slight difference there in what I've shown you. I gave up with the bomb in the background in the end. But you can see there it's done a reasonable job. This last set is quite a good. I think this was around 4,000 iterations, and this was actually done not on the turbo version. It was done on Z image rather than the Z image turbo. The turbo would have actually trained faster, but the nice thing, if you train it on the Z image version, you can use it on either the Z image or the turbo version. So let's do a demo. Now, okay, I should warn you that I'm not running this on my laptop. It's going to take quite a lot of memory. So I'm going to run the demo on my machine at home. So I've remoted into my home machine, and I've got various different models here that I can access. So here's an example model where, yeah, I'll zoom in. So I think this is one of the ones I showed you where we're editing an existing picture. So what I've got here, let me zoom in a bit more. So here I've got the Quen image edit 2511 model, and then I'm loading a LoRA in there. The first LoRA I'm loading is one that someone else has generated called Lightning 4 Steps. This allows you with the Quen image edit model to run a low number of steps. And then the other thing is there's a choice of models. If you've got this is going to run on my GPU, which has got 24 gigs of memory, and that means I can actually run this model, the Safe Tensors version BF16, which is quite big. The alternative would be to run this version of the model, which is a cut down version, which doesn't work quite so well. But this workflow, you've got a choice of running either. If you had less than 16 gig of memory, you'd run the GGUF version of the model, which has been basically, it's been what they call quantized. So rather than having 16-bit values, it's got 8-bit values or less, smaller values. So the BF16 has got 16 values. I think this one's might be a Q3, which means it's got 3-bit values for the model matrix. It just means that it can then fit the thing into memory. So you can see we've got a prompt. I've got this one says make this photo into a drawing in the style of John Willie. So that might be the first step we do. The other thing I could do is load more LoRAs, so I might do that a bit later on. Quite often I decide not to try and do everything at once. So for example, here I might not decide to take this image and try and make her younger to start with. I might do that in a separate model. It's kind of easier to do as a separate step. So, and if you try and do everything at once, it can just take a lot longer because you have to sort of duplicate stuff and but anyway, let's just see how this runs. So I'm going to hit the run here, and hopefully it will go through the various steps, and you get a feeling for it's showing you, the little green box shows you where it's got to. So it's now going into what's called the K sampler, and this is the longest part of the step, and it right at the top of the screen, you can't see it very well, but it's got this green bar that shows how far it's got. So you can see this green bar starting to move across. So the top green bar shows how many steps it's got through. The bottom green bar shows how far it's got through the current step. So now you can see it's converted that picture into a drawing, and I think it's done a pretty good job. So I'm quite happy with that bit. Now I just need to make her look younger. So having experimented with various different processes for making her look younger, I found one, Z-Image Turbo in painting, which and this is quite a good model for that. This set of models I've downloaded from a guy called AI Toolkit, who's on YouTube. I recommend seeing his stuff. He's got some amazing models on the thing. I'll try and when we publish the video, I'll send Steve a bunch of links to different people who I've downloaded models from, which or workflows from, I should say. All the models are tended to be downloaded from Hugging Face or GitHub. So this is the in-painting model, and what the in-painting model will do is it allows you to take try and zoom in on this bit. So here's a picture of Ariel or Jocelyn, and basically if I click on this bit of the model where you're loading the model, it should pop up. It's not done it. It should pop up with a thing saying, do you want to paint over it? I think it doesn't work when I'm remoting in. That's a bit awkward. Can't do it. Let me try. Let's try another image. Let's try that other image. What if it's not doing it? Yeah. Oh, so when I'm sitting in front of the machine, what this allows me to do is to paint over that image with a mask. It seems to have gone a bit wonky. Try again. It's not doing it. Normally it will pop up with a thing, so I'm not going to be able to demonstrate that, unfortunately. So then you can paint over a face and then give it a prompt to say you know, this is Jocelyn, or change this picture to Jocelyn, it would just change the bit that you've painted over. And that way you don't get the thing we had with the cat, where the edit changed it completely. It would just generate a bit that fits exactly into that bit that you've painted over. So, you know, for example, if you had a family photo and you've got somebody you don't want in there anymore, you can just paint over that bit and squash people together, whatever you do, you know. So, sorry about that. Any questions?
Yeah, does this run on your hardware or does it run in the cloud?
This is all running on my big machine that I built a couple of years ago and I demonstrated.
And that means that there's no restrictions.
I can do anything I want on it.
No moral restrictions?
Well, there might be moral restrictions of what I shouldn't do. Luckily, because I had this agreement with Jocelyn that I would do this, I don't have any issues with doing it, because it was her that raised the issue and me suggested it and she agreed. And I've sent her all these pictures I've generated. I've sent to her recently and she's quite happy for me to show them.
Yeah.
Actually added a dress rather than take one off. You've got an AI that puts clothes on women, you'll never sell it, mate.
So you train a model with Jocelyn, and then you've got your own trained model.
Yes.
Tomorrow you could put Becky, some other
Yes,
person.
yeah, in fact,
and it will use your model to do the same with that person.
I've done the same with another friend of mine, my friend Rebecca, and you know, I've shown her the pictures of her playing chess in the park, and she said, if I didn't know I never played chess in the park, I would believe that was a picture of me. So,
so second time you don't have to do any training, because you've already trained
everything once I've got the LoRA trained, I can use it as many times as I like for doing different pictures.
Okay, so you're already taking a trained model, and then you're giving some more content to it, which is basically what you want to give.
Yeah.
And then you're making another model for yourself, and
another picture.
Okay, so at the end of this, you have got a model for yourself, right?
Yeah, yeah.
Okay.
So it consists of two bits: the LoRA, which I've trained myself, and the main model, which was trained on billions of pictures off the internet.
Okay. And you could put.
And I can put them together.
Yeah.
But basically, my LoRA is the adjustments I need on that big model in order for it to know exactly what Jocelyn or Ariel looks like.
So this means that photographic evidence in court is absolutely worthless?
Possibly.
No, aren't there any software which can find out whether this is the other way around?
There are clues. There are clues in the image. But there are already lots and lots of videos on YouTube made this way, because these tools not only work with if you've got a really big computer, they'll work with videos as well. In fact, they would work with videos on my computer, but it would just take a long time and I'd be bored.
It wouldn't work on a laptop.
No, it won't work on an ordinary laptop. You need quite a lot of memory. So one of the alternatives, if you wanted to run it on a laptop, would be to buy a really expensive Mac laptop, because the Mac chips will run the same software, but the main difference is they can use the normal memory of the machine, whereas on Windows you have to have a separate GPU, whereas the Mac chips themselves have a built-in GPU.
What if you have a cloud account?
Well, that's it. You could do all this on a cloud. You can go to a cloud provider, and there are some that specialise in ComfyUI. So you can go and hit a button, have a copy of ComfyUI all installed, ready to go, and put your models in there. Choose your models that you want to use. You could train a model, train a LoRA on there. Then you're going to be paying so much per cycle, and it's, as I said, you can borrow a big machine that runs faster, or a cheap machine that runs slower, and decide which is the best for your budget.
So your model is nowhere in the cloud now?
No, I haven't released it to anybody, because I think I might give it to Jocelyn, and she might decide that she wanted to release it, but I wouldn't release it without her permission.
Does that mean you don't need her to take any more photos of her?
In theory.
You know that.
Have you tried, so you went from 2025 to 2012.
Yeah.
I see a lot of Instagram, 2025 to 2050. Did
Yeah.
you try anything?
I haven't
Show me
tried
how
making
the-
her older. I haven't had a need for that.
I would warn
Don't push
you
her like that.
against that.
She's done her best to look young anyway. She's spent a lot of money on various different procedures. She's actually, believe it or not, you try and guess her age. She's actually 45. So.
Wow.
So.
If you're using
In fact, she's 46 now. She's 45 when I took that picture.
So does that model understand the concept of time? I mean,
No.
are you...
No. I could get it to I could create something by training multiple LoRAs. I mean, you can build in there, like a stack of LoRAs. So I could have one for when, like, 12 years ago, one for 10 years ago, one for, and then tell it which one by using different keywords. But I haven't done that.
Right.
And that's not needed for what I want to do, so I haven't.
So does it take the environment also? So 1970s, 1980s, obviously the park that you see, clothing that you see.
If you're talking about generating a picture, a lot of those models do know about time, so you can say generate a 1960s street scene, or generate a futuristic. A lot of them will watch films from the future, like whatever, and so you can ask it to generate pictures that look futuristic. No problem. You can ask it to generate pictures from different countries. You can say, show what it looks like with Jocelyn in front of the Taj Mahal, and it would do it. Or you could say, show Jocelyn in New York, and it would know what a New York street scene looks like, and it would do it.
So the only bottleneck is the resource.
Yeah, and it takes a few minutes. As you can see, you saw how long it took to generate that picture. It just takes a... The nice thing about the turbo models and Quen with that turbo add-on bit is that they're both quite quick. You only need 4 or 5 steps to do it. Some of the other models, like if you're running the full Z image model, the main difference with the full Z image model is a bit more flexible. Basically, to make the turbo version, they cut down the model in a certain way, so it tends to generate very similar pictures. So if you generate a picture of a person standing in a forest, and then change it to a picture standing in a street, you would look at them and you'd think they've got exactly the same pose, and the things in the forest, the trees in the forest, they're in exactly the same place as the buildings in the street, and it's difficult to get a lot of variation. Whereas in the Z image base model, you can get much more variation. It's a much bigger model, but it takes a lot longer because it needs 30 steps, not just 4. And it also, because the model's so big, the only way to get it to work on my machine is to chop it into bits and load bits of the model and then unload them and then load more bits in. So it gets really slow.
So all these modules, are they free open source?
All this is open source, yes.
Right.
It's generally stuff that's written in Python, and it's available to download from Hugging Face or some similar place.
Great. Well, thanks very much for that.
Yeah.
Thank you.